Hello everyone, I am Ms. Hu, your physics teacher. In this video, I'm going to go through electric current. What we'll be covering in this video are what is electric current, the formula for electric current, conventional current versus electron flow, as well as direct current and alternating current. So first of all, what is electric current? So electric current is something that is flowing inside the circuit. So let's say in this diagram, this thing represents an electrical conductor. And if we connect this electrical conductor to a circuit with a power supply, there will be current flow. Now the thing is, you need to know what is this thing that's creating current. When we say current flows, something has to be moving. So you must remember that when it comes to electricity, the particles that are causing the current flow are electrons. So let's say we've got a whole bunch of electrons here. The electrons are moving through the conductor. So electric current is actually the movement of electrons through the conductor. So you must remember that metals are usually excellent electrical conductors because there are free moving electrons, or sometimes described as delocalized electrons. That means the electrons are not fixed in place, they are free to move. So that's what makes metals such excellent electrical conductors. So based on this understanding, how do we calculate electric current? So the definition of electric current is the rate of flow of charge. Now, we know that electric current is actually the movement of electrons, but if you look at the definition, they don't talk about electrons. It's about the rate of flow of charge. So what you must understand is that electrons are actually charge carriers. So the electric current is actually a measure of how much charge the electrons are carrying. The formula for the electric current is I equals to Q over T, where I is current, which we measure in ampere. Q is the value of the charge, which is carried by the electrons, which we measure in coulomb. And T, of course, is time, which we measure in seconds. Electric current is not the measure of how many electrons are passing through, but rather how much charge the electrons are carrying per second. So you can think of it as how much charge is flowing through a point. So let's say if this is the conductor and there are electrons flowing through it, we are measuring how much charge is flowing through this point per second. So there are electrons flowing through, you measure, okay, how much charge? So there are a lot of electrons, the electrons are carrying charge. What's the total value of charge flowing through this point in 1 second? So how do we relate charge with the number of electrons? So another formula you need to be aware of is this. So if Q is the total number of charge, N is the number of electrons, and E is the charge of one electron. So this formula should make sense because the total value of the charge is how many electrons there are multiplied by how much charge each electron is carrying. So this Q and this Q are the same. So I'm just going to draw an arrow to indicate that. N is the number of electrons. So there's no unit for that. While E is the charge of a single electron. And the value of this is 1.6 times 10 to the power of negative 19 coulomb. Now don't worry, you don't have to memorize this number. This number will be provided to you in the exams if you need it. So for these two formula, the value of Q is actually the same. So you might need to combine these two formula if you ever need to relate current to the number of electrons. So you need to use both formula if you ever need to relate the value of the current to the number of electrons. You would calculate the total charge first using this formula, and then use this formula to figure out the number of electrons. Now let's take a look at the directions. So you must know the direction of the conventional current as well as the direction of the flow of electrons. Now when they write here flow of conventional current, it also just means the same thing as flow of current. So if you see current or conventional current, the flow direction is the same. They are referring to the same thing. Now let's take a look at this circuit. So this is a cell and this is a lamp. When you see a cell, you must remember that the longer line represents the positive terminal, while the shorter line represents the negative terminal. So current or conventional current always flows from positive to negative. So this is the direction of the conventional current, which I'm just writing here as current. Electrons flow in the opposite direction because electrons are negatively charged. So you can think of the negative terminal is where the electrons start from, which is why it's the negative terminal. And because negative charges are attracted to positive, electrons, which are negatively charged, will move towards the positive terminal. So the electrons are moving in the opposite direction. Now, in case you're ever wondering why, let's understand the history of the circuits. So when it comes to setting up a circuit, think about it. You can't actually see what's moving in the wires, right? We can only see whether the circuit is complete or not and whether the light bulb lights up. So when electricity was discovered, we didn't actually know what was happening in the wires. So we figured out, hey, there's current flow. So to distinguish between the terminals, we set one as positive and the other as negative. So let's just think about it. So if someone mentions there's something flowing from one terminal to another, do you think automatically that it flows from positive to negative or negative to positive? So most people would think, yeah, positive goes to negative. So that's why current is stated as flowing from positive to negative. But later they discovered actually current is due to the electron flow. But electrons are negatively charged and electrons flow from negative to positive. Now, what's actually happening in the wires? The particles that are actually moving are electrons. So yes, the particles are actually moving from negative to positive terminal. Is there actually anything moving from positive to negative? No, there's actually nothing flowing in the opposite direction. So the current direction is just an arbitrary direction that is used to help us remember current better. So there's actually nothing flowing from positive to negative. It's all electrons moving from negative to positive. So why do we keep the understanding of current even though it doesn't actually exist? It's because it's easier for most people to remember and understand. So that's why we keep this arbitrary direction, and that's why it's called conventional current, because it's the traditional expected way of remembering things. So as physics students, you need to be aware that yes, even though current doesn't actually exist, you must know that current flows from positive to negative, while electrons flow from negative to positive. So just to help you remember, here's a little meme for you. And now let's go into the concept of measuring current. So to measure current, we use a device known as an ammeter, and the ammeter must be in series with the components of the circuit. So how you can remember the connection is that current is essentially the rate of flow of charge. So you want to measure how much charge flows through that point in the circuit in 1 second. So that's why the ammeter must be placed in series, because it marks this is the point where we're measuring the flow of charge. That's why it must be placed in series with the rest of the components in the circuit. So for ammeters, there are digital ammeters as well as analog ammeters. When connecting the ammeters, we must make sure that the positive terminal connects to the positive terminal on the ammeter, while the negative to the negative. Digital ammeters are very easy to read. However, if you're not sure how to use an analog ammeter, I do have videos which explain how to use and adjust the analog ammeter, and I've placed the links to those videos in the description below. Now, the types of current. You must know that there are direct current and alternating current. Direct current is DC for short, while alternating current AC for short. What's the difference? Direct current is current that flows in one direction only. So you can think of it as direct current means that the current flows directly from one point to another point. Examples of direct current include dry cells and car batteries. So for direct current power supplies, there is one fixed positive and negative terminal. So here are the symbols of some of the DC power supply. This is a cell. Batteries are made up of more than one cell. So sometimes it could be drawn like this with multiple cells clearly shown, or it could be drawn this way. That means there are many cells making up the battery. Sometimes you could also draw the power supply this way, where they just label the positive and negative. For the symbols that look like this, remember that the longer line always represents the positive terminal, while the shorter line represents the negative terminal. Now, alternating current, on the other hand, is current that changes direction periodically with changing magnitude. So examples of sources include the AC generator, as well as commercial and residential power supply. The symbols that represent AC power supply typically look like this. So they might either have just circles to represent the terminals here, and they may or may not have this wiggly line in between. So the wiggly line here represents the alternating current. That means the current is changing in terms of the magnitude and direction. In the case of the AC power supply, there's no positive and negative terminal. In terms of the AC power supply, there's no fixed positive and negative terminal. That's because the positive and negative terminals are constantly changing. Because if you connect the AC power supply to a circuit, what happens is the current will flow one way and it'll flow the other way. So that means the positive and negative terminals are constantly changing. First, let's say positive and negative, current will flow to the negative, and then they swap. Now this becomes positive, current will now flow the other way to this negative terminal. So the current's constantly swapping. So that's why it's called alternating. It's alternating in terms of the directions of the current. And that is it for this video. So if you found this video to be educational and helpful, please click like and subscribe for more free physics lessons. Do check out my YouTube channel for videos on other topics which you might find helpful. If you'd like to help me keep making free educational video lessons and lab practicals, donations are welcomed at my Ko-fi page. That's ko-fi.com/physicsrocks. If you'd like access to notes, quizzes, and syllabus updates, do check out my website at physicsrocks.com. Happy studying!